Welcome to The Explainer. You know when you pick up a product, look at the packaging, and wonder, is this 100% eco-friendly claim actually backed by science? Or is it just pure marketing? Well, you're in the right place. Today, we're breaking down exactly how we accurately measure sustainable packaging to avoid greenwashing. We're literally looking under the hood of corporate sustainability reporting to see the precise technical rules companies must follow to prove their materials are actually circular.
Okay, let's dive right into this. To understand how incredibly strict these rules are, we kind of need to know where they come from. This framework carries a serious stamp of authority. Back in August 2022, the ISSB, that's the International Sustainability Standards Board of the IFRS Foundation, actually assumed responsibility for the SASB standards. So what does this all mean? It means the metrics we're about to explore aren't just arbitrary, feel-good guidelines. They're part of a highly authoritative, globally recognized framework that the world's biggest corporations use to report their sustainability risks to investors.
So here's our game plan for today. We'll start with the SASB packaging standard, then move on to defining true recycled content and what counts as renewable. After that, we'll look at the recycled and renewable overlap, and finally wrap up with calculating the final percentages. Let's get to it. All right, Section 1, the SASB packaging standard. Let's look at product lifecycle management within the containers and packaging industry. Here's the core objective of the standard we're analyzing today, metric RTCP 410.1.1. The whole purpose of this metric is to track the percentage of a company's raw materials that come from three specific buckets: recycled content, renewable resources, and a combination of those two. Now, the absolutely crucial point here is that this isn't some vague qualitative description. It is strictly quantitative. Everything here is measured as a percentage by weight, so it's all about physical mass, plain and simple. Moving on to Section 2, defining true recycled content. According to the strict ISO 14021 definitions adopted by the standard, recycled material isn't just, anything that gets a second life. It's specifically defined as material reprocessed from recovered or reclaimed material through a manufacturing process and then made into a final product or component. The magic word here? Reprocessed. The material absolutely has to undergo an actual manufacturing transformation to count. You can't just take a used cardboard box, slap a new label on it, and claim it as recycled raw material weight. It doesn't work that way. Now, what's really interesting about this slide is what it explicitly leaves out. To be recycled, a material first has to be recovered, and the standard defines recovered material as stuff that would have otherwise been discarded as waste or used for energy recovery, but was instead collected as a material input. Notice that little caveat? Used for energy recovery. If a company just burns its scrap cardboard to generate heat for its factory, that completely disqualifies it from being recovered material. Burning it simply does not count. It literally must be repurposed as a physical material input. The standard goes even further and breaks down recycled content into two very distinct sources: pre-consumer and post-consumer. Now, post-consumer is what we usually think of, right? Material generated by households or commercial facilities that can't be used for its intended purpose anymore, like that empty plastic bottle you toss in the recycling bin. But pre-consumer? That's where companies often try to stretch the truth, and where the SASB standard stops them in their tracks. Pre-consumer material is diverted from the waste stream during manufacturing. But here's the catch. The standard explicitly excludes materials like rework, regrind, or scrap that are reclaimed within the exact same process that generated them. So if a machine cuts out a plastic cup and immediately melts down the leftover plastic trim to make the very next cup, no way. That does not count as recycled content. That's just basic manufacturing efficiency. All right, Section 3. What counts as renewable? For this part, the SASB standard aligns with the Consumer Goods Forum's Global Protocol on Packaging Sustainability 2.0. Renewable resources are defined as materials composed of biomass from a living source. But here is the critical part, the absolute golden rule of renewables. The material must be replenished at a rate greater than or equal to the rate of depletion. It's a really simple but totally unforgiving ratio. If you're cutting down bamboo even slightly faster than the bamboo forest can grow it back, well, that bamboo is no longer classified as a renewable resource for your packaging. Period. So, what exactly qualifies as biomass to meet this standard? Well, it has to be of biological origin, whether living or dead. This includes materials from both above and below ground. We're talking trees, crops, grasses, tree litter, algae, animals, and even waste of biological origin, like manure. But look closely at the strict exclusions here. The standard specifically excludes peat, and it completely excludes materials embedded in geological formations or anything fossilized. This just goes to show the incredible rigor of the standard. It makes absolutely sure that ancient carbon sinks, like peat bogs or petroleum-based plastics, can never be greenwashed into the renewable category. Next up, Section 4, the recycled and renewable overlap. So the standard tracks raw materials that are both recycled content and renewable resources simultaneously. It actually demands that companies isolate the weight of raw materials that satisfy both of these definitions. Why? Well, because renewable resources can come from both virgin and recycled sources. Think about a cardboard box made entirely from post-consumer recycled paper. Paper comes from trees, which are a renewable biomass, right? And it's being reprocessed from a recovered state, meaning it's recycled. The standard requires companies to track this overlap perfectly. This way, investors can see the exact intersection of the circular economy and renewable ecosystems right there in a company's supply chain. Which brings us to Section 5, calculating the final percentages. Let's move to and see how this builds from definitions to the actual accounting math. To get our final percentages, we obviously have to divide our eco-friendly materials by the total amount of materials used. So the big question is, how do we accurately calculate the total weight of all raw materials consumed in a given reporting period? Answering this sets up the denominator for all three of our percentage calculations. The SASB framework gives us a very clean, undeniable inventory equation for this. You can kind of think of it as a timeline of a company's warehouse. Step 1, you take the total quantity of materials sitting in the raw materials inventory at the exact beginning of the reporting period. Step 2, you add the total weight of any purchases of materials made during that period. And finally, step 3, you just subtract any materials still left sitting in raw materials inventory at the end of the reporting period. What you're left with is the exact total weight of all inputs, both recycled and virgin, that were actively processed to be sold as finished goods. There's zero guessing here. It's just pure, straightforward accounting. However, there's a highly specific technical caveat that we absolutely need to point out for paper products. When you're calculating these percentages for paper-based packaging, you don't just weigh the final product. Why? Because paper often includes water weight, coatings, or some pretty heavy adhesives. So the standard states that the percentage must be calculated using specifically the fiber weight of the raw materials from recycled content divided by the total fiber weight of all raw materials. This ensures a true apples-to-apples comparison and totally prevents companies from using heavy non-recyclable coatings just to skew their total material weights. And this brilliantly illustrates how all of our hard work parsing those technical definitions actually pays off. Once you've navigated the strict rules of ISO 1421 for recycled content, and the Consumer Goods Form's rules for renewable biomass, and you've isolated your overlapping materials, the final output is just a simple percentage. You literally just take your specific targeted material weight, that's your numerator, and divide it by the total processed weight, your denominator. It takes incredibly complex, rigorous supply chain tracking just to produce one simple, transparent number for the public. Which leaves us with this final thought. We see claims of eco-friendly and green packaging on store shelves every single day. But as we've just seen, true sustainability isn't just a catchy marketing slogan. It is rigorous, auditable math based on strict replenishment ratios and exact inventory tracking. So if a corporation boasts about eco-packaging but can't provide the precise inventory math required by RTCP 410A.1, you really have to ask yourself, are they truly building a circular economy? Or are they just selling you a story? Definitely keep that in mind the next time you look at a label. Thanks for joining Mrs. Explainer, and keep questioning the data.